All right, circles. Here are the definitions of things you need to know about circles in order to answer the questions and stuff we got to do. First of all, a circle, set of all points in a plane that are equidistant from a given point. What kind of plane is that talking about right there? Not one that flies. What does a plane mean in geometry?
Attention, all football players, please report.
All right, what kind of plane is this talking about? You might tell me? What a plane means in geometry. Nobody.
Oh, yeah.
A plane is simply a flat surface that extends forever in all directions. So if I took this board right here and went left and right forever, up and down forever, that would be a plane. So, set of points equidistant from a given point. You start with a point. That point you start with is the center. So when I start with the center, I put it down, and then I say I'm going to go 4 feet away from that. So if I went 4 feet and marked it, there would be my circle when I got done. All right, radius, segment from the center to any point on the circle. Chord is a segment whose end points are on the circle. Diameter, chord that goes through the center. Secant is a line that intersects it in 2 points. And tangent is a line, ray, or segment that intersects in exactly 1 point. All right, here is what they actually look like. Make sure you have this diagram. That's what all of those things, the definitions on the previous page, that's what they look like, and you have to be able to identify them. All right. What was the first one was the center. So there's our center point right there. What was the next definition that had on there? Radius.
Radius, yeah.
Notice the radius does this. Starts at the center, goes to the circle and stops. Starts at the center and goes to the circle. Now, if I know one radius, every other radius has to be the exact same. Because all the endpoints going around are the same. So if I start in the center and go to any one of them, those are going to be the same. Next one is what? Diameter?
Yes.
A diameter goes all the way across the circle, but the important part is this: it has to go through the center. If it does not go through the center, it is not a diameter. All right. Next one was chord. Chord is on the circle. The endpoints are on the circle. Now you can have small chords. You can have long chords. You could have this right here is a chord. Just that much. That's a chord. As long as it starts and stops on the circle, it's a chord. Is a diameter a chord?
No, it is. Or yes, it is.
Yeah, it starts and stops on the circle. It just happens to go through the center, and that's what makes it a diameter. What was next? The secant is a line that goes through the circle and hits it twice. But it's important that it's a line. What is this right here? From that point to that point. That's a chord. So a chord is inside of a secant.
It's like an arrow.
You've got to have the arrows on the end to keep going to make it work. All right? And then tangent is hits the circle at 1 point and that's it. Now, it can be like this and be a segment. It could be a ray, or it can be a line. All of those would still be a tangent. And this is a different type of tangent than the trig ratio stuff we just did. All right, here's what I want you to do on this. Give me all of the possible answers for each one of these. So radius, there's more than one radius up there. I want you to label the radius. Make sure you remember this down here in the corner. A line segment, you use the 2 letters. A line has the line symbol above it, and the ray has the 1 arrow symbol above it. All right, so give me all of the possible answers for those right there. If I'm looking at radii, which is the first one. What's the deal with the radius? What do you do?
It goes halfway.
Well, what do you do with it?
It goes from the center.
From the center out to the circle. So I'm going to start at the center every time. Well, if I go out here to F, there's a radius. But that's not the only one, because I can start at G and go up there to B. And then I can also go from G to E. So you should have 3 radii up there. A secant, what is the deal with a secant?
It goes, all the way across.
It is a line that goes through the circle. It hits it in 2 spots. The only line I see up there that goes through the circle is,
AB.
and you've got to have that little line symbol above it. Because if I do this, what am I talking about there,
It's
AB?
going from point to point.
That's going from point to point and stopping. That's a segment. A secant cannot be a segment. It's got to be a line. Tangent,
I only see one, that's C to A.
it hits the circle 1 point. Well, the only one that does that is CH. Now, ray CH would be the answer. Could I do this and say ray HC? No, because this means the H has the point and the C is where the arrow's going. That won't work. But up here, go back to the first one, I could say FG and be fine, BG and EG. I can switch those around. I can't switch a ray around. Chord. Now there's quite a few chords up here. Give me one.
B.
B is a point. A chord is a segment. It's got to have 2 letters.
I said BE.
Oh, BE, my bad. BE would be 1.
B.
BD would be 1. We're missing 1.
BA.
BA. But notice the difference between this AB right here and this BA. This one stops because it doesn't have anything above it. This line AB for the secant keeps going forever. Diameter, there's only one of those.
B.
All right, are there any questions on how to identify this stuff? Because if you can't identify it, you're not going to be able to do anything else. All right, this is very simple. Don't even copy it down. What would the radius be on this? How long?
B.
It'd be 3 spaces, right? Everybody see that? 1, 2, 3, and I'm at the end. What about diameter? So what is the relationship between the radius and the diameter?
The radius doubles to make the diameter.
The radius is half as big as the diameter, or the diameter is twice as big as the radius. So if you know one or the other, you automatically can find the other one. So if I said the radius is 5, the diameter would be
10.
If I said the diameter is 12, the radius would be
6.
Any questions there? If you know the radius, you got the diameter. If you know the diameter, you can find the radius. All right. Get that one copied down on the tangents. There's different types. All right. On tangents, we have a couple different types. Common external. Why do you think it's called external? This one right here. Well, I'm not going to say on top. I'm going to
It
say
hits both of them on the outside.
outside. It's outside the 2 circles. Whereas this one right here
Goes in.
goes in between the 2 circles. So that's why it's called a common internal. So you have common internal and common external tangents. All right, what I want you to do on this is draw all of the possible tangents you see. Remember, it can only hit the circle 1 time. And it's got to hit both circles 1 time to be a common tangent. How many common tangents can I draw on that first one?
4.
All right. Give me, tell me one.
The external right there on the top. You go
External on the top would do that.
and external on the bottom.
External on the bottom would do that.
Then you can do internal on the inside both of them.
Yep. You got 4 common tangents on that one. Now,
I did it on top of that.
but now it's got to hit both circles. Each tangent has to get both circles. Now, and a lot of times I'll see people do this right here. And they'll say, oh, well, I'm going to do that right there and stop and make it be a tangent. The problem is this. You've got to be able to extend it and see what would happen. So if I extend it, I go through the circle. That doesn't work. So again, you've got the 2 internal there and the 2 external there. All right, what about number 2 with the overlapping circle?
There's 2, you can go external. both.
External and external. That's all you can do. What happens with doing that right there? I'm hitting a circle and going through it twice. Same deal over here. I hit the circle and go through it. Can't do that. Certainly can't go through the middle. All right. Look at those. How many common tangents do I have on the first one?
2. Next one.
Most everybody sees those. And they miss that one.
That's the one we got.
I put it in the middle.
I can draw it in the middle. It's going to hit that circle once, hit that circle once, and not hit anything twice. So that one would have 3 common tangents.
I'll put that.
Number 4,
1.
Kill the other side. 2. Circle hit the other side. Can they count as the circle good?
It counts.
am I here?
1.
Yeah, 1.
Yeah. That one's got 1.
The next one's 0.
And this one is 0 because any tangent for the inside circle is going to do what to the outside circle?
Hit the outside.
It's going to hit it in 2 spots, so that won't work. So, when we're talking about common tangents, you can have 0 up to 4, depending on the way the circles are configured. All right, get this rule copied down. All right, this rule says a line is tangent to a circle if and only if the line is perpendicular to the radius at the point of tangent. All that junk, what you need to get out of it is this. I know this line is tangent if it makes a right angle right there. All right. Now, I do want to talk about this. When it says if and only if, that means the rule that they're talking about can be reversed. So, a line is tangent if it's perpendicular, if it makes a right angle. But then I can turn it around and say if it makes a right angle, then what do I have to know? Then it's got to be tangent. So it's tangent if it makes a right angle, but it's a right angle if it's tangent. Those rules switch. What you need to get, if you see a right angle, that's got to be tangent. If it's tangent, you know it's going to make a right angle. All right, so I see this right here. It's asking me, is BC, this bottom one, tangent to circle A? Well, how do I know if it's tangent? What does it have to make?
A right angle.
Has to make a right angle. Well, how can I check and see if it's got a right angle? Not just look at it, prove it with some math. How can I prove that that's a right angle in there?
Oh, the triangle. Because the radius thing, the radius thing.
But how can I prove that that's a right angle in there?
By the measurements of the triangle.
What you said? Because the line thing, the radius, not the radius, but
The theta. Okay.
No. No, it's something simple that I can check and see if that's a right angle.
man, the triangle.
Oh,
If Pythagorean theorem works, what does that tell me about the triangle? It's a right triangle, and if it's a right triangle, it's got to have a right angle. So all I've got to do is check does Pythagorean theorem work for that. If it does, then that tells me right triangle, and if it's a right triangle, then it's got to have a right angle in there.
don't if it.
So I'm going to check, see if this works.
240.
Remember what 24 is.
40. What's that, 40?
It's 400.
Oh, it is 48. 47. Oh,
Is that right? No, that's not right.
It's
we got
566.
566. Whoa.
We got average.
Is that right?
All right.
Somebody have a calculator?
I had a calculator.
Let me check.
Check that. All right, so what does this tell me right here when I get the same number on both sides?
He's about 10.
That means, yes, it's a right triangle. And so if it's a right triangle,
It's 26 times 26.
then I have the right angle. So to answer the question, now I got to get to the answer to the question. Is BC tangent?
Yes.
Yes, because it makes a right angle.
Yeah.
All right. So what you've got to check, does it make a right triangle if it gives you something like this? All right, check that one for me. So when I want to check this one, again, it's BC tangent. I'm going to do Pythagorean theorem and see if it makes a right triangle. So 16 squared plus 19 squared equals 27 squared. 256, 3,
61.
61, and 729. So this winds up being what?
617.
617? 617 equals 729. So what does this mean? Not a right triangle.
So that means it's not tangent.
So this tells me
That's,
not tangent because it doesn't make a right angle. So if it's something like this, we're checking, is it a right triangle? If it's a right triangle, then it makes a right angle, then it's tangent. If it's not a right triangle, then it's not a right angle. Won't work. See how smart we are right here.
I'm so smart.
radius is halfway, so that makes that 16, right?
All right, here's the part you got to get on this. If I know that this radius is 5, that radius is 5,
That's what it was.
which means this whole thing up here is actually
Ah,
13. So I would do 5 squared plus 12 squared equals 13 squared.
missed it.
So yes, that's right triangle. So
First of all, I missed it anyway. I
You
said
must-
12 plus 12 is 24.
all right. So make sure if you're missing the radius, fill it in with whatever the other radius is.
That's